Dual nature of matter and radiation. Light behaves both as a wave and particle. A particle is confined at a place. On the other hand, a wave is spread in space. The nature of light depends on the nature of our observation. If we are observing phenomena like the interference, diffraction and reflection, we will find that light is a wave. If we look at the phenomenon like photoelectric effect, we find that light has a particle character. So the question is, which is it, a wave or a particle? The answer is, it has a dual nature. Does only light have a dual nature? What if other quantities had dual nature? How can I measure and prove that? These questions led Louis Victor de Broglie to come up with an equation. In 1924, Louis de Broglie proposed that matter has dual characteristics just like radiation. His concept about the dual nature of matter was based on the following observation. The observations are: the whole universe is composed of matter and electromagnetic radiations. Since both are forms of energy, so can be transformed into each other. Second one is the matter loves symmetry. As the radiation has dual nature, matter should also possess dual character. Third one is, according to the de Broglie concept of matter waves, the matter has dual nature. It means when the matter is moving, it shows the wave properties like interference, diffraction, etc. are associated with it. And when it is in the state of rest, then it shows particle properties. Thus the matter has dual nature. The wave associated with moving particles are matter waves or de Broglie waves. Here in the image you can clearly see this is your de Broglie wave. Let us derive a formula for the wavelength of de Broglie wave. Consider a photon whose energy is given by E is equal to hv is equal to sc by lambda. If a photon possesses mass, then according to the theory of relativity, its energy is given by E is equal to mc square. This is your second equation. From equation 1 and 2, we have mass of photon m is equal to h by c lambda. Therefore, momentum of photon P is equal to mc is equal to sc by c lambda is equal to h by lambda. This is your equation number 3. So, from these equations, lambda is equal to h by p. This is your wavelength of de Broglie wave. Now, what is Einstein's equation of photoelectric effect? Light consisted of very small particles. These particles were not matter but pure energy. He called each of these a quantum of radiation. So light must be made up of these quantas or packets of energy. We call them photons and they carry the momentum and energy from our source of light. So according to the Einstein-Planck relation, we have E is equal to hv, where h is the Planck's constant and v is the frequency of the radiation emitted. In equation 1, we see that energy is a function of frequency. Hence, this observation is explained by equation 1. This also explains the instantaneous nature of photoelectric emission. Once a photoelectron is outside the metallic surface, since there is no electric field outside the metal surface, the energy of an electron will be purely kinetic in nature. So we have kinetic energy of the photoelectrons is equal to energy obtained from the photon, the energy used to escape the metallic surface. This energy is a constant for a given surface. We denote it by phi. We call it the work function and it is constant for a given substance. So kinetic energy is equal to hv minus phi. This is your equation 2. So guys, we just briefly discussed about dual nature of matter and radiation, de Broglie concept and the equation for Einstein's photoelectric effect. For detailed study of this chapter, just visit to our website www.syft.in. Thanks for watching us.